Hello everyone. In this video, we will cover the essential elements of requirements documentation. First up, we will define what an SRS actually is. Next, we will discuss how to represent requirements. We will also examine the key components that make up a comprehensive SRS and talk about the ideal size for this document. Finally, we will give you some top tips on writing an effective SRS. Before we get started, let's have a quick recap of the 4 essential phases of requirements engineering. We begin by discovering requirements from stakeholders. We've discussed several elicitation techniques, such as interviews and questionnaires, along with their advantages and disadvantages. Then we move on to analyze these requirements, focusing on how to classify and prioritize them. Currently, we're in the phase of documenting requirements. In the upcoming video, we will explore requirements validation and verification to ensure that we are building the right system and building the system correctly. In the previous lecture, you learned that the output of the requirements documentation process is the Software Requirements Specification, or SRS. The SRS is a document that serves as the blueprint for a software project. It details the features, functions, and constraints of the software, acting as the main reference point so that all stakeholders have a clear understanding of what the software will do. Consequently, the primary users of the SRS are stakeholders, including customers, managers, and many others. Now, let's explore the different ways to represent requirements. There are 3 main approaches: formal, semi-formal, and informal. The formal approach typically involves mathematical notations and is often implemented using languages such as Z or VDM. Because formal methods employ mathematical notations, they are precise and unambiguous. However, stakeholders who are not technically inclined may find formal specifications difficult to comprehend, potentially creating a communication barrier between technical and non-technical members of a project team. You will learn more about this in the Formal Methods module. The semi-formal approach is generally done via UNL, the Unified Modeling Language. Some examples of UNL include the class diagram and sequence diagram. You should already be familiar with these diagrams, as they were covered in the System Design and Analysis module. Lastly, we have the informal approach. This method is less structured compared to the formal and semi-formal approaches and involves describing the software requirements in plain, everyday language. It's the most accessible form because it allows stakeholders who may not be familiar with technical notations to understand the requirements clearly. However, because of its lack of formal structure, it can sometimes lead to ambiguities or misunderstandings. Based on a survey conducted by Neil and Laplant in 2003, we can see that semi-formal methods are the most widely used for requirements notation, with informal methods also being quite prevalent. Formal methods are less utilized, accounting for under 10% of reported usage. It is important to note that SRS will generally be composed of more than one type of representation. For instance, even if we are representing our requirements with UNL, we will still need to use natural language to explain these diagrams. Now, you might be wondering what we should include in an SRS. Let's start by taking a look at the ISO IEC IEEE 29148 standard. This standard provides a template with guidelines for the processes and products involved in engineering requirements throughout the life cycle of systems and software. ISO stands for the International Organization for Standardization, IEC for the International Electrotechnical Commission, and IEEE for the Institute of Electrical and Electronics Engineers. These 3 are prominent international standards organizations that develop and publish international standards for a vast array of industries, spanning technology, electronics, and engineering disciplines. Unfortunately, the template isn't free. However, a quick online search can reveal a preview of this document. Here is a snapshot, which you can see on the right-hand side of this slide. Even so, we can take a quick glance at the table of contents of the IEEE 29148 standard. I must say, the items covered are quite comprehensive. It calls for a very detailed introduction, including scope, overview, limitations, and then progresses to present both functional and non-functional requirements. Clearly, the IEEE 29148 standard isn't the only one out there. There are numerous free templates available for use. I'll show you 2 examples here. On the left-hand side is an SRS template by Asana, and on the right is one provided by Tara AI. If you look through these, you'll notice significant differences in the table of contents of these templates. It's crucial for you to understand that there are no fixed guidelines for the content of an SRS. The key is to communicate with the users of this document and understand their expectations for the SRS you are going to produce. Now that you understand the components required for its SRS, you might be wondering, how extensive should this document be? It's common to assume that it would be a very lengthy document. However, according to a study by Neal and Laplant, a significant majority of SRS documents contain fewer than 25 pages, and very few requirement specifications extend between 251 and 500 pages. This suggests that most SRS documents are designed to be concise, prioritizing ease of use and clarity. Therefore, again, the rule of thumb is to actively communicate with the intended users of your SRS to understand their specific needs and expectations regarding the document's size and detail. All right, we've already taken a look at the components of an SRS and discussed how concise it typically needs to be. But how do we make sure it's not just concise, but also crystal clear and really effective? I'm going to share with you some expert recommendations here. First up, consistency is key. Stick to a standard format for all your requirements. This keeps everything clear and organized. Next, we need to keep the language consistent too. You should also consider using text highlighting to make crucial parts pop. This makes your document way easier to scan through. And one more thing, ease up on the technical jargon. Only use complicated terms when they're absolutely necessary. And when you do, add a quick note in the glossary. For instance, make sure everyone knows RPC means Remote Procedure Call. Here, you can see two examples of how these requirements usually look in an SRS. Notice how they're both clear and to the point. That's what we're aiming for. Just as it's important to know the best practices for crafting a clear and effective SRS, it's equally crucial to understand the common mistakes that can undermine its clarity and utility. First of all, avoid hedging clauses like "if necessary," which can introduce ambiguity into your requirements. Be clear about why something is necessary and under what conditions. Never leave room for interpretation in your SRS. Next up, words like perhaps and sometimes. These might seem harmless, but they can actually introduce a lot of doubt and weaken your requirements. So, it's best to avoid them altogether. Similarly, avoid vague terms like user-friendly. It sounds good, right? But what does it actually mean? User-friendly can mean different things to different people. Instead, specify what you mean by user-friendly. Lastly, be cautious with conjunctions such as and, or, but. These can lead to multiple requirements crammed into one statement and cause confusion. Here you can see an example of what to do and what not to do when writing requirements. So, in this video, we covered what requirement documentation is, why it's crucial, its suggested content, and how to create effective documentation. If you found this video helpful, don't forget to like, subscribe, and click the bell icon for more updates. Please also share your thoughts or questions in the comments below. Thanks for watching, and see you in the next video.